Hi, this is King of Review. So here we have to express the log base 28 of 63 in terms of a and b, the log base 2 of 3 and the log base 2 of 7. Now a big problem right away is that we have a base of 28, whereas what we want, a and b, each have a base of 2. So we can use what's called the change of base formula for logarithms. And the change of base formula looks like this. If you have the log with some base b of some number a, and you want a log with a different base, let's call it c, then we can write this as a fraction. The log with base c of a over the log with base c of b, the original base. If we apply that to our problem and choose a base of 2, just like a and b, then our log becomes the log base 2 of 63 over the log base 2 of 28, the original base. Okay, now we still need to turn 63 and 28 into 3 and 7, since those are the numbers in a and b, so let's see if we can factor 63 and 28. I know that 63 is 9 times 7, but I'm not really looking for 9s, I'm looking for 3s and 7s, so let me factor 9 further into 3 times 3. 63 is the same as 3 times 3 times 7. Doing the same thing in the denominator, I know I'm looking for 3s and 7s, since that's a and b, and I know 7 goes into 28, it's 7 times 4. Now 4 definitely doesn't have any 3s that go into it, but since I know the base of my two logs, a and b, is 2, 2 is an important number in this problem too, and of course 4 is 2 times 2. So 28 factors into 7 times 2 times 2. And now all the numbers we have in our logs are the 3 numbers in the logs in a and b. So we can use another very nice property of logs that says if you have a log with some base of the product of two numbers, say x times y, you can split that up into the log with your base of x plus the log with the same base of y. So applying that here, we can split these up into separate logs, 3 separate logs in the top, one with the first 3, one with the second 3, and one with the 7. And then the denominator, we will have the log of the 7 plus log of the 2 plus the log of the other 2. Now this is going very well because our first term, log base 2 of 3, that's a. Our second term is also log base 2 of 3, that's another a. Then we have log base 2 of 7, that's b. In the denominator, we also have log base 2 of 7, that's b. And now if we want to figure out the log base 2 of 2, let's think about what it means to find a log. The log base 2 of 2, if we want to figure out what this means, this is equivalent to writing in exponential form 2 to what power equals 2. The 2 from the base comes from the base of the log, and the 2 that it equals comes from the number inside the log. Well, since 2 to the first power is equal to 2, our question mark must be equal to 1. So I can fill in 1 for these last 2 logs. And if we simplify this fraction, we get 2a plus b over 2 plus b. And that's what we see over here in answer choice D. And there's our answer. Thanks for watching.